Allow me to introduce FiltrX, a company specializing in the engineering and creation of high-quality water filters.
The primary focus of our team was to have a very thorough filter. To achieve this, we used a 1-inch in diameter by 6-inch long housing so that the water would have enough medium to successfully be filtered. We also decided to use activated charcoal as the medium. We came to this decision when we realized that many filters used domestically also use activated charcoal. To us, the additional cost of activated charcoal was worth paying for the better performance offered by it.
Here is a picture of the filter along with the Arduino and spectrophotometer that is used to determine the clarity of the dirty water after it has traveled through the filter. Duct tape was placed around the dowels to connect it to the bottle that is placed on top of the filter. We also use duct tape to seal the filter to prevent it from allowing dirty water to escape while it is running through the filter. And we also use the duct tape to connect the dowels together to create a structural support for our filter. In this view from above, one can see that dirty water is poured into the cut-open bottle that was placed to fulfill the 500 milliliter holding capacity stretch goal. Upon being poured into the bottle that is placed above, the dirty water flows through the charcoal, which then filters out the red dye, allowing the remaining clean water to land in the bottle below. In this view from below, we demonstrate our decision to place rubber bands on the exit of the housing to serve the purpose of keeping the filter paper in place, thus holding in the charcoal. The tripod-like design was used to elevate the filter and also create structural support as it squeezes the bottle that is below it, allowing it to be freestanding, and also have the filter at a level where if we had 500 milliliters, it would be capable of allowing all the remaining water to be placed in the bottle below.
This video shows our water filter in action. As previously said, the wooden dowels around the filter stabilize the apparatus. First, our undergraduate TA measures 10 milliliters of water and pours it into the reservoir above our filter. The dirty water then flows down through the duct tape section between the reservoir and the activated charcoal, passes through the filter, and drips into the Gatorade bottle at the bottom of the apparatus. Here is a close-up of the bottom of our filter.
Performance was a key part of this project. With this in mind, we did our best to keep our costs as low as possible without limiting the many variables that enhance performance. As a result, the final weight of our filter came out to be just under 245 grams in a housing that fits inside a 3x3 by 20.5 inch container. Our filter allows water to flow through at a rate of 7.23 milliliters per minute, removes 99.65% of dye, and has a mere 0.014 absorption coefficient, all for a price of $235. Our calibration curve shows the concentration of the dye water solution on the x-axis and the absorbance rate measured by our photometer on the y-axis. Our curve is somewhat skewed due to an outer lying point at x equals 1, y equals 0.25, and we believe that human error is to account for this miscalculation, as all our other points are much more consistent with each other and the official testing point.
Our completed filter cost $235. Most of this money went towards paying for the housing and the medium, which each cost $70. In addition to this, we also spent $40 on 2 water bottles, $30 on 6 8-inch wooden dowels, $15 on filter paper, and $10 on duct tape. Our first iteration only used 1 package of activated charcoal, which worked fine on the more diluted dirty water. However, after the concentration was increased later on in the semester, we decided that the performance of our filter wasn't good enough, so we decided to add an additional packet of activated charcoal to improve our filtration. If there was more time, it would have been interesting to try steel wool as an alternative way to hold the activated charcoal in the housing. I believe the steel wool might have increased the flow rate because it would not have absorbed as much of the water. In addition to this, steel wool would have also reduced the costs, as it was $10 cheaper than the filter paper.
This concludes our presentation. Thank you for watching.